Find the polynomial with real coefficients of least degree so that f of 0 equals 40 and the polynomial has zeros at 2 and 1 minus 2i. So we're going to have to use a lot of the stuff we've learned about polynomials. The fact that we're going to have least degree means I want to keep the number of zeros as low as possible. So I know I have 2, at least 2, right? I have to have zeros at 2 and 1 minus 2i. I want to introduce as few as possible. I know I need to introduce at least one more because I'm supposed to end up only with real coefficients. The conjugate pairs theorem tells me that if a plus bi is a complex root of a polynomial, then so is a minus bi its complex conjugate. So 1 minus 2i is a root. Its conjugate 1 plus 2i also has to be a root. So even though it wasn't listed, this complex root along with this one is why we can end up with real coefficients. All right, well I have zeros at 2, 1 minus 2i, and 1 plus 2i. I want to keep that list as small as possible, so that's it. Those are going to be my zeros. I want them all to have multiplicity 1, again, to keep the degree as small as possible, so I'm going to end up with a degree 3 polynomial. The linear factorization theorem tells me that I can express my polynomial as a product of its linear factors. So if 2 is a 0, then x minus 2 has to be a root. If 1 minus 2i is a 0, then x minus 1 minus 2i has to be a root. And the same thing here, x minus 1 plus 2i has to be a root. So this is the product of linear factors, and then I have to think, well, maybe the leading coefficient's out there. And I'm just going to call the leading coefficient a. And so, to state this polynomial, I'll need to find out what a is. And I also want to make sure it really does have real coefficients, so I need to multiply everything out. And so here's kind of the labor-intensive part. I need to multiply the linear factors together. I'm going to start with these two, because if I can multiply these two together, everything else will be fairly easy. So I'm going to do that on some scratch paper. So I'm going to take x minus 1 minus 2i and multiply it by x minus 1 plus 2i. For convenience, I'm going to use what a lot of folks call the FOIL method. I'm just distributing, but I'm going to pretend that this is x minus a number, because it is x minus a number, and so is this. So I'm going to go first, outside, inside, last when I multiply these together. X times x is x squared. I need to multiply the outside terms together. So I have minus x times 1 plus 2i. I need to multiply the inside terms together. So I have minus x times 1 minus 2i. And then finally, I need to multiply the last terms together. A minus times a minus, I'll get a plus 1 minus 2i times 1 plus 2i. So simplifying this, I have x squared, and I'll distribute this minus x through. Minus x minus 2ix minus x plus 2ix. And here I have the product of complex conjugates, so I know that's a squared plus b squared. So that's 1 plus 4 is 5. Very nice. I get no imaginary part from this part, and 2ix and minus 2ix cancel. So I end up with x squared minus 2x plus 5 when I multiply those together. So I can go back to my original problem now and just replace this with what I wrote on the other board. So that'll become x squared minus 2x plus 5. So bring it over from my scratch work. A times x minus 2 times what I got when I actually multiplied this together. All right, now I need to distribute x minus 2 through this polynomial. So I have a times x cubed minus 2x squared plus 5x minus 2x squared, and I'm going to keep track of that down here. I'm going to combine my like terms, or write my like terms together as I go, plus 4x minus 10. All right, I need to combine those like terms, and then I'll be ready, hopefully, to find A. So I'm going to take this and copy it down. I'll have a minus 4x squared and a plus 9x. So that function I'm trying to find is A times x cubed minus 4x squared plus 9x minus 10. So part of the problem was to get a polynomial with real coefficients of the smallest possible degree. We decided that was 3, so we've got that done. I'm only supposed to see real coefficients. We have that, and now I just need to find A. And we're told at the outset of the problem that f of 0 is equal to 40. So I can plug a 0 in for x, and I know the y value is supposed to be 40. Well, if I plug a 0 in for x, those vanish, and I just get a minus 10. And so A is equal to minus 4. At this point, I've really kind of finished the problem, but I want to go on and just do that one more step to simplify it, where I distribute that minus 4 through. And there is our final polynomial answer. It's a polynomial of degree 3 with real coefficients with zeros at 2, 1 minus 2i, and 1 plus 2i.